Okay, so today we're going to spend another day talking about continuity, but rather than focusing on sort of what continuity is or how to determine where functions are continuous or not, what we're going to do is look at one of the applications of continuity. So by knowing what continuous means, it allows us to prove other things, and we're going to look at one of those things today. So we're actually going to skip the first page of the notes. This is an activity we're going to do in class tomorrow, and we're going to start with a theorem on the next page called the intermediate value theorem. So what I did here is I provided you with the text of the intermediate value theorem, and I thought we could start by reading through it and then maybe making some annotations about what this actually means, because theorems can be very dense and it can be hard sometimes to understand what they mean, so it's probably better to write some of this down as we're talking about it. So the intermediate value theorem says, if f is a function that is continuous over the interval from a to b, and m is some number between f of a and f of b, then there exists a number c between a and b such that f of c is equal to m. When you first read that, it probably pretty much sounds like gibberish. So we're going to break it down, and we're going to think about this as an if-then statement. Now you may remember if-then statements from geometry. The if is what's called the hypothesis, and the then is what's called the conclusion. It allows us to say that if these things are true, then this must be forced to be true. So as long as we meet these conditions, what we usually call the if is the conditions, then these are the consequences. An example just sort of using regular English would be if your parents ever said, if you clean your room, then you can go to the movies. The if is you clean your room. That has to happen first. If you don't clean your room, nothing else happens. We can't guarantee whether you can go to the movies or not because you didn't satisfy the conditions. Then you can go to the movies means these are the consequences for cleaning your room. So the consequences in this case are positive. You would get to go to the movies. There are some times when there are bad consequences. For example, you might say, if you don't clean your room, then you're going to be grounded. So if you don't clean your room, that would be the condition. Then you're going to be grounded. Those would be negative consequences. So this intermediate value theorem has conditions and consequences. The first condition is that your function needs to be continuous over the closed interval from a to b. So this is condition number 1. Now it is significant here that this is a closed interval. What that means is that it is continuous including the endpoints. So everything on the graph for the specific interval that you're looking at is nice and smooth and connected, including the endpoints of the graph. Now the second condition, so and m is some number between f of a and f of b. Now you'll notice here this doesn't say a and b, it says f of a and f of b. So m is going to be a y value. And f of a and f of b are going to be the y values at the endpoints. So if m, which is the number we want to talk about, is between the numbers at the endpoints, the y values, then, now here's the consequences. So as long as you're continuous and the number that you want is in between the endpoints, then there must be, so when they say there exists, they mean there must be a number c. It's not optional. It has to be a number between a and b. So between the x values such that the y value at C is equal to M. So let's look at a graph and see if we can talk about what this makes sense. The first thing is we need to meet the conditions. So is this function continuous between A and B? Well, since this function is nice and smooth and connected, the function is continuous between A and B. So that's condition number 1. Now, condition number 2 is that M, the y value that we want, is between the y values of the endpoints. Well, since A is here, A's y value is here. B is here, so B's y value is up here. Let's say this was like 2 and this was like 7. M, which is the number that we want, is in between those two y values. So if this was 2 and this was 7, M could be any number in between there. Then there must be a place somewhere on the graph so that the graph crosses through that y value. Well, if I trace M over, M is the y value of this x value. We're going to call it C number 1. M is the y value of this y value. We're going to call it C number 2. And M is the y value of this point, which is C number 3. And all 3 of those x's are in between A and B. So how do you know when you need to use this theorem? We must use the intermediate value theorem whenever we are asked to guarantee that a function attains a specific y value. So the directions will say, can you guarantee that your function equals 7? We're being asked to guarantee a specific y value, so we would use the intermediate value theorem. Now, we're going to look at the conditions. Condition number 1 is that we have to be continuous over our interval. And condition number 2 is that the y value that we want needs to be between the y values of the endpoints. We're going to think about those two things specifically. And we're going to look at these functions, and you're going to have to figure out why you can't use the intermediate value theorem here. So let's take a look. For the first function, the function in problem number 2, it says consider the function f of x equals this guy, find c between -3 and 4, such that f of c is equal to 2. Well, this is asking us to guarantee a specific y value. So before we can do that, we need to make sure that the conditions of the theorem actually apply. So we're going to look at this graph specifically between the x values of -3 and 4. So -3 is here. That's the first x value. And 4 is here. So we're going to look at the graph only between those two numbers. Now, in order to apply this theorem, in order to make guarantees, we need to be continuous, and the number that we want needs to be in between the numbers of the endpoints. So, the first thing is, are we continuous? Well, looking at this chunk of the graph, I can see that there's an infinite discontinuity at 3. So I would say the intermediate value theorem does not apply because f of x is not continuous on this interval, because there's a huge infinite discontinuity somewhere in that chunk of the graph. Let's look at another example. So consider this function, this graph. Find a value between -1 and 4 so that the y value is equal to -2. So again, we're being asked to guarantee a specific y value. So let's see. -1 is here. 4 is here. Now my first condition is that I need to be continuous in between those numbers. So if I look here, I am nice and smooth and connected in between those numbers. Great. Now my second condition is that the y value that I want needs to be in between the y values of the endpoints. So if I look at where x is -1, the point on the graph where that happens is here. So this, the 0, is my y value at that endpoint. Now, if I look at the points on the graph, the place where x is 4, the other endpoint, is here. So that's my other y value. Is the number -2, the one that I want, in between these two y values? No. So because that y value that I want is not in between these two, I cannot apply the intermediate value theorem. Now you might be thinking, but wait a second, Mrs. Vasta, it does have a place where the y value is -2, and you're right. But just based on this theorem, I would not be able to guarantee that. So I would say that the IVT does not apply because -2 is not between f of -1 and f of 4. So now that we kind of know when this theorem doesn't apply, we're going to look at when it does apply. So let's look at the next page. These directions say, can you guarantee that f of x is equal to 0 on the given interval? Now, as soon as you see this, where we're being asked to guarantee a specific y value, you know you're going to be using the intermediate value theorem to do that. What's going to matter here is how you process through the problem and how you write your answer, because we are going to be very, very particular and specific about the way you write your sentences. These answers are going to require sentences. So in order to make this guarantee, the first step is to see if our function is continuous. So step number 1 is, are you continuous? Well, this is a polynomial. It's an x cubed graph, which means there are no discontinuities. We don't have a rational function. We don't have a piecewise function. There's no asymptotes. We're good. So yes, we are continuous. The second question is 0 between f of -2 and f of 4? So in order to figure that out, we're going to have to calculate f of -2 and f of 4 and see if 0 is in between those two numbers. Well, let's take a look here. I'm going to type in 25 minus 8 times -2 squared minus parentheses -2 to the third power, and I get 1. And I'm going to type in 25 minus parentheses 8 times 4 squared minus parentheses 4 to the third power, and I get -167. Now, because one of these numbers is positive and one of these numbers is negative, 0 is between these numbers. Since we are continuous and the number that we want to guarantee is actually between these two numbers, we can use the intermediate value theorem to guarantee that we actually cross through that value. Here's how you would write that. You would write, since f of x is continuous and now one of these numbers, the negative 167, is less than 0, and one of them is bigger. So we would say f of 4 is less than 0, which is less than f of negative 2. We can guarantee f of x equals 0 on the interval negative 2, 4 by the IVT. Now I know this seems like a lot to write, but I want you to think about this as sort of a fill in the blanks. You're always going to start with since. You're going to fill in the name of the function. So I'm going to put boxes around the part that you fill in. Is continuous and then you're going to fill in this part. There's always going to be one endpoint that is less than the number that you want to show, that you achieve, is less than the other endpoint. We can guarantee that f of x equals that number, that's part that you fill in, on the interval, and you're going to fill in that interval by the IVT. So other than those 4 boxes, everything that you write will be the same every time. Now logically, let me show you why this one makes sense. What we just figured out was that we have a nice continuous function. And when x is negative 2, my y value is a 1. So there's definitely a point here. When x is positive 4, my y value is negative 167. Because our function is continuous, we have to connect the dots nicely and smoothly. Now there's lots of different ways to connect the dots. You could add in a few extra squiggles, it doesn't matter, but it needs to be nice and smooth and connected. Which means at some point, to get from here to here, you have to cross through 0. There's no way to get from the positive 1y value to the negative 1y value without crossing through 0 along the way, as long as you're continuous. If we were not continuous, if this was not true, if there was a jump or an asymptote, then this theory is broken because we could have just jumped over 0. But since we are continuous, there's no way to get from the top to the bottom without crossing through everything in between. Let's take a look at one more example. So, can you guarantee that f of x is equal to 3 on the given interval? So again, this time we want to guarantee this y value is 3. The first question is, are you continuous? Now again, we have the same function as before. So yes, we're continuous because it's a cubic function. There's not going to be any asymptotes or jumps or anything like that. The second thing we need to know is the number 3 in between f of negative 2 and f of 4? So we're going to try to figure out f of negative 2 and f of 4. Now, lucky for us, we actually already calculated both of those numbers in the previous example. So we get 1 and negative 167. Is the number 3 in between these numbers? Well, no. Negative 167 and 1, the number 3 would not be in between there. So since 3 is not between these numbers, we would say that since 3 is not between f of negative 2 and f of 4, we cannot guarantee f of x equals 3 on this interval. Now again, just like the last one, think about this as like a structure. You're just going to kind of fill in the blanks. You're going to fill in the number you're trying to get and the values of the ends. You would say we cannot guarantee that we equal that number on that interval. Everything else here would remain the same. You wouldn't really have to do any changing of those words unless the issue was that you weren't continuous, in which case you would just say, since f of x is not continuous, we cannot guarantee this. We're going to talk about this some more tomorrow. Again, we're going to do a little activity to hopefully solidify the conceptual understanding, and then we'll also maybe do one or two of these other examples before I let you try some problems. So thank you so much for watching and listening, and I will see you tomorrow. Have a great day.